Some of the show commands that we should know in MPLS is show MPLS LDP neighbor. This will show MPLS LDP neighbor. This will show you the established MPLS neighbors list of neighbors with whom LDP neighborship is established. Means with whom LDP can share the updates. And if you don't see an update, if you don't see a neighbor, after configuring MPLS, if you don't see a neighbor, then there is a trouble. How do we troubleshoot? First, we will check whether MPLS is really enabled on the interface. The command is show MPLS interfaces. This will show you what all interfaces MPLS runs. And if you find some interfaces, good. And if there is an interface missing, go and enable. Enabling MPLS is simple, right? Go to the interface and say MPLS IP. That's all. MPLS space IP. That's how we enabled MPLS in the previous class. So this command show MPLS interfaces will show you the interfaces under which MPLS is enabled. Now let us assume MPLS is running on both sides, means configured on both sides properly. MPLS is configured on both sides correctly on all the interfaces, but still the neighbor is not there. Interfaces are up. I'm able to ping the address of the directly connected device. What may be the problem? The problem is something which you cannot even imagine. So I do not want to wait for you to answer for this question. I'm going to give you the answer. Let me repeat the problem again. Yeah. Now we went inside all the router and we said MPLS IP, MPLS IP, MPLS IP, the global mode. After that, you also went to the interface and repeated the same command. Right? Only this much is what we need to know to enable MPLS. But after enabling MPLS, when I try to check for neighbor, show MPLS LDP neighbor, I'm not seeing neighbor. Then I tried pinging this address. When I try pinging the directly connected router's IP address, I'm able to ping. I'm able to ping. Ping is okay. But still I'm not able to find neighbor. You just think, I don't want to give you an answer. You just think what might be the problem. Or if you want to ask me a question, you can ask. Okay, there is one chance. But by default, all the CEF is enabled on all Cisco device. We have not disabled them. We have not at all disabled them. So think. Okay, ask me question instead of answering this. Ask me question because the answer is not under your um, thinking limit. That's why I want you to think. Let me see who goes closer to the solution. Ask me question. Come again. OSPF, yeah, it is there. OSPF for static root. But neighbors are not forming. Neighbors are not forming. You can ask more question, like see OSPF is running here. OSPF is running here, no OS issues. No issues. OSPF is running here. OSPF is running here. We have OSPF neighbor, but MPLS neighbor is not coming. No, I'm not asking question. I want you to ask more question to find solution. All right, I do not want to make you wait for a long time. Listen, OSPF picks a router ID. Likewise, BGP picks a router ID. MPLS also picks a router ID. Now the difference is for OSPF and BGP, the router ID of neighbor doesn't need to be there on interface, doesn't need to be there in the topology. For OSPF, you may configure a router ID which is nowhere exist. Correct? For OSPF, you can configure router ID that address that you configure as a router ID that need not to be available on that device or anywhere in the topology. Not necessary to be there. But for MPLS, MPLS will pick a loopback interface address as a router ID. Manually also, if you want, you can assign a router ID for MPLS, but make sure that address is reachable. Make sure that address is reachable. So we don't have OSPF running here. See, no OSPF on loopbacks. As a result, router 1 don't know 2.2.2.2 and 3.3.3.3. So when router 2 try to negotiate LDP, router 2 says, I am coming from 2.2.2.2. And router 1 says, I don't know you. Router 1 says, I don't know who is 3.3.3.3.3. But router 2 and 3 will use that loopback interface address as the router ID to communicate to R1. R1 don't know about this too. You understand? Simple. The router IDs of MPLS should be a pingable address. Did you get the point, Sam? What did he say? You see, let me repeat. See, if OSPF is running on this two interface, no problem. There is no problem for MPLS informing neighbor. When OSPF is not there, in the routing table of R2, there won't be routes to reach 22222. 3333. This route will not be available. And now when router 2 comes and negotiates with the router ID 22222, router 1 will say, I don't know you, I don't have a route to reach you, so I cannot form neighbor with you. You understand? So when I enable OSPF, when I have OSPF, I have the routes. In the routing table, I have the routes. So when negotiation comes with the router ID 22222 and 33333, router 1 can respond. All right. So these are some show commands. There are more show commands that we always use in MPLS. I'll give you at least another two. You know the purpose of this, you know the purpose of this. Now, the next one is show MPLS. Show MPLS forwarding. This command will show you the forwarding table where for each prefixes you will see local label, outgoing label, gateway address, and the interface to exit. And it will also show how many packets have used the labels. I showed you this output earlier in the class. Show MPLS forwarding table. This is the forwarding table of MPLS. It can also be called as label forwarding information base. Now there is another show command which will show you mrib, MPLS routing information base. This is lfib, forwarding base. MPLS routing table. Show MPLS binding. Binding table. Right? So these show commands will help you to troubleshoot, will help you to verify. I don't use any other command for troubleshooting MPLS, though there are many. Sorry. How many commands are given? I think just 4. Just 4. For MPLS, this is enough. Or additionally, may I add like show sef. And then the destination network. This will show you the sef entry as well as the MPLS label. I showed you even this command in the previous class. There is nothing more needed actually for MPLS. Now, did anyone try doing lab in the previous, means after yesterday class? Have you done this lab? So what I encourage you to do is now, instead of continuing to new syllabus, do small topology, minimum of 6 routers, and enable MPLS and use these commands. Use these commands and try learning what they can show, so that when I give you a scenario, a troubleshooting scenario, you will be able to fix it. See, MPLS, configuring MPLS is simple. One command, MPLS IP. But troubleshooting really takes a lot of time. If we don't know that CEF is involved, OSPF is involved, OSPF need to run even on the loopback interface, because the router ID is what important for MPLS, because MPLS is not a routing protocol. So MPLS cannot form neighbor with someone you don't know. The router ID of the neighbor should be reachable. So when we don't know these things, we'll not be able to understand where the problem is. Secondly, to find the problem, you need to know some show commands. So in order to know whether the OSPF is running on interfaces, show IP OSPF interface brief you put, or at least type show IP route and check whether the router IDs of the neighbors are reachable. Right? So do this lab and we'll meet tomorrow. We'll continue from here. Do you have any question? Take at least 6 routers. Yes, please. Come again. See, as of now, the portions covered to you in MPLS is very little. Means we learned only MPLS fundamental, the basic MPLS. For this UN, you can have a RIP protocol or static route. But when we do MPLS advanced, it is only the link state routing protocol recommended. OSPF or ISIS, both are link state routing protocol. Any other question? So use only OSPF, please, all of you. When you do this lab, as I say, take 6 routers inside the MPLS core. Additionally, 2 routers if possible, if your GNS supports as a customer router where you will not run MPLS. Don't run MPLS. Yeah, it is important to have single flat area. Multi-area is not recommended. Welcome. These are all very good questions. Very good questions. Multi-area is not recommended, though it is possible, but not recommended. Single area, single flat area. What happens is when we have multiple areas, you know about OSPF, type 1 and type 2 LSAs are not sent to the other area. So detailed LSAs are available only within the area. The identical database is only seen within the area. This is because of OSPF limitation. The detailed LSDB is only seen within an area, identical within an area. So when you have a detailed identical LSDB, MPLS can be more efficient. Whereas when we have multi-areas, as I say, type 1 and type 2 of one area will not go to the other areas. So sometime summarization and stub configured on other area may limit the information in the database. As a result, MPLS cannot find best switching path. So to have a very best switching path, it is good to have an identical link state database, for which we need to have one common database, a flat OSPF single area topology. Any other question? See, in ISPs, where we have MPLS, it is only between the PE routers, and in the middle we may have few. 1 minute. If only one area, then we cannot have too many routers in OSPF. That's true. You cannot have too many routers. So we need to design our network in such a way that all the PE routers sits in one single area. All the PE routers that connects to customer. That is what even ISP likes it. They don't want customer to be in different area. So all the customers will be in single area, and the services like DNS servers and so on will be in another area going through area 0. So if it is needed for customer to use the DNS of the provider, only then it will go between different area. Only for WAN services, it will enter in one area and it will leave out on the same area. It is not like we are not having multiple areas. We have multiple area, but MPLS runs on a single area. Devices on a single area. This is how I have seen in reality. All the PE routers that connects to the customer are in same area. Can you visualize what I'm saying, Girish? Okay. You see, the PE routers what is PE router? The provider edge routers. They're the one who connects to the customer. Now these routers should be in same area. Right. Now customer enters here, it may leave this way or this way or this way. They're connected to other autonomous systems. The other area is here, area 0. You may have many areas like this. Those are all for internal purpose. This area may have some server firm. This area may have some data center related, something like that. See, service provider is an organization. Like in enterprises, they are also having different departments, multi areas. One of the department is providing WAN service. For that, they have one area 52. Traffic enters. So this is still in single area. Yeah, question. Yes, I can. Yeah, correct. No, this is middle one. This is area 0. This entire thing is ISP. The entire whatever you see in the picture is ISP except this. These are all customers connecting. The purple rounds or small rounds are customers. And this is area 1, this is area 2, this is area backbone, and that is area 52. So this is one big autonomous system. Customers, ISPs are basically networks. Whatever customer has got, the ISP will also have like various departments, multi-area. One of the service that ISP provides is the WAN connection for the customers. So here they have given one area for the customer to use. Yes. Mm. Mm. Okay, I understand where you're going. See, our aim is not here to see how the customer routes are going to go through the provider. It's not BGP class. We'll talk about that later. You've just started MPLS. What you're asking is a VPN service, which we have not even started in MPLS. So, along with BGP, MPLS can provide you a layer 3 VPN. Through VPN, it will go, so you will not be redistributing. Don't worry. I know what you're trying to ask. From BGP knowledge, you're asking. So, those things are not necessary because we are going to have a tunnel between provider edges with one route reflector in the middle. Later, we'll see that. So, provider networks and customer networks, no way they're going to get mixed. They will never get mixed. Anything else? Fine then. Do this.